Why don't spacecraft freeze in space? Heat, temperature, and the physics of the vacuum. Anyone who has ever been curious about space has probably asked this question at least once. If space is so cold, why don't spacecraft freeze? At first glance, the question seems simple, but behind it lies a surprisingly deep subject involving physics, engineering, thermodynamics, and even how we understand the universe itself. What's more, finding a truly detailed and clear explanation of this topic online isn't easy. So in this video, we'll build the answer from the ground up, step by step. To understand this properly, we must first clarify two concepts that are often confused: heat and temperature. Heat versus temperature. Heat is a form of energy. Whenever energy flows from one object to another due to a difference in temperature, we call that energy heat. In simple terms, a hotter object transfers energy to a colder one. This process is known as heat transfer. Temperature, on the other hand, is a measure of the average kinetic energy of the atoms inside a substance. The faster these atoms vibrate, the higher the temperature. For example, boiling water has a high temperature because its molecules move very rapidly. But that doesn't necessarily mean it contains a large amount of heat energy. Heat depends on how much energy can actually be transferred to another object. In short, temperature tells us how hot something is. Heat describes the flow of energy between objects. Confusing these two concepts makes it much harder to understand how temperature behaves in space. Units of measurement. Heat is measured in joules, or sometimes calories. 1 calorie is defined as the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. This is where the calories we talk about in daily life come from. They're simply units of energy. Temperature, however, is measured in Kelvin, Celsius, or Fahrenheit. In scientific work, Kelvin is almost always used. That's because 0 Kelvin represents absolute zero, the theoretical point where all molecular motion stops. Kelvin uses the same scale as Celsius, but with a different starting point. 0 degrees Celsius equals 273.15 Kelvin. Kelvin never has negative values. This makes it ideal for scientific calculations, especially in physics and engineering. Celsius is what we use in everyday life. Water freezes at 0 degrees Celsius. Water boils at